Problem number 15 is definitely a tricky one. They tell us that this binomial times this binomial is equal to this trinomial. So we basically have the factored form of the expression on the left and then the non-factored form, the expanded form on the right. It says this is true for all values of x. They do provide us with a little bit of information about a and b, so they don't tell us the values of a and b, but they do tell us that a and b sum to 8. And then it says what are two possible values for c. So what I thought whenever I looked at this was, well, maybe I can FOIL out the left-hand side of this equation and start to get somewhere. So when I did first times first, I got this term. When I did outer times outer, I got 7ax. Inner times inner is 2bx. And then last times last is positive 14. So when I FOIL out the left-hand side of this equation, I know that it has to equal to the expanded result that we see on the other side. So couple things to point out here. I've already highlighted the AB and the 15 in yellow. And the reason why that's significant is because the only term on the left side of the equal sign with an x squared attached to it has a coefficient of AB. And on the right hand side, the only coefficient of x squared that we see there is 15. So this process is called equating coefficients. I know that a times b, the coefficient of x squared on the left side of the equation, has to equal 15, the coefficient of x squared on the other side. So ab is going to equal 15. You see I've already copied this equation down that we were presented with within the problem statement. And then in green, what I highlighted were the coefficients of the x terms on the left, 7a and 2b. And then the coefficient of x on the right is c. So the 7a and the 2b have to combine to c in order for the left side of this equation to be equivalent to the right side. And then 14 is equal to 14. So I don't really have to do anything with those. It kind of confirms that, yeah, the constant terms on both sides of this equation match up. But we're going to be able to use what we just built right here in order to solve this situation. So if you notice what I've boxed here, I've boxed a plus b equals 8, what we were provided with, and a times b equals 15, which we got from setting the coefficient of x squared on the left side of the equation with the coefficient of x squared from the right side of the equation. This right here is a 2 by 2 system, 2 variables, 2 unknowns. We should be able to solve that system. So what I did is I took this equation and I subtracted b from both sides. So I got a was equal to 8 minus b. I was then able to substitute 8 minus b in place of the a in this next equation. So I have 8 minus b times b equals 15. This is a quadratic equation. If I was to distribute this b in, I would end up with 8b minus b squared equals 15. Quadratic equations typically have two solutions. Now if you're dealing with quadratic equations in a non-calculator setting, usually, not all the time, but usually, rather than using the quadratic formula to solve that equation, solving by factoring is going to work, and it's going to be a much more efficient alternative. So what I did is I added the b squared to the right-hand side, I subtracted 8b from the right-hand side, and I only did that because when I factor, I like when the coefficient of the variable that's squared is positive, so that's why I elected to add the b squared and then subtract the 8b. And once this equation is set equal to 0, you want to build your product, build your multiplication problem, factor the other side. So if I try to unfoil this, first times first has to give me b squared. Last times last has to give me positive 15. And the O and the I from FOIL has to give me negative 8b. So if you double check that, you'll see that b minus 3 times b minus 5 is the proper factored form. This factor is equal to 0 when b is positive 3. This factor is equal to 0 when b is negative 5. So what that tells us is that there's two possibilities for b, 3 and 5. So if b is equal to 3, what's a going to equal? Well, a and b still have to multiply together to give 15 and sum together to give 8. So if b is 3, a has to equal 5. And if I put 5 in place of this a, and I put 3 in place of this b, that'll tell me my first possibility for c, so I get 41 after doing that. And if I go with this second answer that I got for b, so if b is 5, a would have to be 3 in order for a and b to sum to 8 and multiply to 15. And if I take this value of b and this value of a and plug it into this bottom equation, I end up producing my second possibility for C, which is 31. So definitely weird, definitely lengthy. Hopefully that made some sense.